Scientists can determine the age of an ancient object by radiocarbon dating. A parchment fragment was discovered that had about 74% as much carbon-14 radioactivity as does plant material on Earth today. Estimate the age of the parchment if you know the half-life of carbon-14 is 5,730 years. So there's a lot of information there. So we need to try to figure out this. We're going to use the same formula that we would use for a population because essentially we're looking at the population of the carbon in the object. So that formula is going to look like the amount at time t. It's not technically a population like a people population. So we'll say the amount is C e to the kt. So we don't know how much carbon we had originally, but we know we have half of it now. So we're going to say that the amount at our time t, well, we don't really know what it was, but we know that it's half of the amount originally and our original amount. Well, we made a little bit of progress, e to the k. So how long does it take for it to get to half? Well, it looks like it takes 5,730 years for us to get to half. So 5,730. So if we divide both sides by c, these will cancel. And then we'll be left with 1/2 equals e to the 5,730k. To cancel our exponent with the variable, we can use our natural log. The natural log and the e cancel, so that'll leave us with the natural log of 1/2 is equal to 5,730k. So we'll divide both sides by the 5,730, and it looks like k will be about negative 0.000. I need to move my k over. I didn't leave enough space. 12097. So that's a big number for k. I recommend just storing that one in your calculator because we need to use it again, but that'd be a lot to type back in. All right, so now we can write our formula because we have our k value now. There we go. We still don't know our value for C. Well, what do we have in the problem that we haven't used yet that will help us get to a value of C? If you notice, it said 74% as much. So we don't know actually what our value is, but we know it's 74%. So that would be 0.74 of whatever the original amount was. So we can use that. So negative 0.123120917. It's a lot to write, but that's our k value. We can divide both sides by c. So we'll have our 0.74 equaling e to the negative 0.123120917. We know that we need to take the natural log because that is how we get our t out of the exponent. So if we do our natural log, we get the natural log. Oops. Let's try it again. The color went crazy. Here we go. A 0.74 is equal to negative 0.12312097. And then we can do our division. And if we do our division, we get 2,489 years equaling t. So we would anticipate that this piece of parchment that was discovered was about 2,489 years old. And that's based on the carbon that was left.